Right. So yeah, there are like six pillars what we can say on a cloud for AWS. So they call it as well architecture framework. So the operational excellence pillar, security, reliability, performance efficiency, cost optimization, sustainability. So these are the important pillars. So when you are a architect, right? Let's say you are providing solution to your customer. So you will have n number of options, right? Like there will be like whatever problem you have, whatever solution you're going to provide for that problem, and the use cases. So you will be having n number of solutions, right? But it is always matter for a company or for an organization who want to consume this AWS cloud, and the architect want to provide a solution for their problems. So he should be like he or she should be like able to provide with perfect solution with all this by following all these well architectured frameworks, right? So because there may be some options where it might increase your cost, but there might be some options where you will compromise on the security. So there might be some solutions where you cannot do a with excellence. Like there may be some problem when you complete your deployments, and when it comes to the operation, there may be a lot of problems in the operations. So it should be always should be like well architecture based on these six pillars. So they divided it to six pillars, right? So let's go through each one by one. So operational excellence, yeah. So as I said, the when you are new to cloud, you will be doing a solution. You will be yeah, assessing your, let's say, your on premises, and you want to migrate all your infrastructures to the cloud, and you will be creating a architecture for that, right? Maybe because in the on premises you will be using your virtualizations, or let's say physical or virtualization VMs, and you will be using some database or application servers running on the VMs, and there will be a lot of different infrastructures you will be following, you'll be having, right? In on-prem, like you will be having a separate storage infrastructure, and you will be having a backbone network, like where you use a physical load balancer or a virtual load balancers, or you will be using some firewalls, with virtual or physical firewalls. So there will be a lot of architecture, uh, changes when you are going to the cloud. So you have to consider that when you have a architecture change, you have to also consider about your operations, right? Operations like post migrating your applications, how the applications, the infrastructure for the applications will be managed. So that they have some design principles, like you have to do a code that is always recommended. So instead of doing things manually, you do things do code, so that there will be if there is any changes or anything, so you can track on that, and you can do a versioning and all that, and your infrastructure will be if it is a code, then your operations can be performed as a code. Let's say if you want to fix something, you don't need to go and fix it once, and that should not occur again. So if you are fixing the code, then it's kind of a permanent fix, and it will be like whenever you rerun the same code again, so it will whatever fix you have done, so that fix will be implemented, right? So, and there is like make small and reversible changes. So instead of changing, let's say you have a I'll give you an example here. Let's say you have a on-premises systems, right? You are running a physical server, and your customer are saying go and patch your servers. Maybe from you want to patch from major version to minor version or something, right? So if you are patching, you don't know what impact it causes to your application. Let's say if you are running some Node.js or some applications, right, on Node.js. So because of you patched your system, so your systems are not, your application is not coming up. So the reversing this change is it's quite a little difficult in the on-premises comparing in the cloud, right? Because when you are doing a code, when you are doing your infrastructure as a code, and you have an option to just stop all this updated servers, and create a new new EC2 instance for your application with the older versions, right? So you don't need to do all many things, like you are you need to perform on the on premises. So that is one of the best example, like when you want to change, in the cloud. So you will always have a code, and you will always have a uh, like backup or snapshots which can be used to just reverse the changes whatever we are making, right? And refine operation, you have to make sure that the whatever change you are doing, it's not it's not a very a big change as part of a single change. You have to split it, and you have to do it like maybe as a different changes, so that it will be easily reversible, and it will be easily you will be able to easily identify the issues where which change is it's creating, right, on, so that you can easily revert that particular change. So, and anticipate failures and learn from all operational failures. So these are the important refine operation procedure frequently. So you have to refine your operation procedure, because you may be using some services now, but you may feel that few of the services are getting updated. So you can start using those services. Then you have to change your operational policies as well as, right. So because earlier I know people used to do their monitoring they have their agents running on each of the VMs, and they will be monitoring. There is one team who monitors all the systems, and there will be a ticket created, and they'll raise a bridge, and all that will happen, right? So I mean, still many people are following that, but now it's completely like instead of when let's say when in terms of cloud, right, when let's say when a particular VM is down or VM is not working, it's not about wasting time on fixing that VM, right? It's about bringing back your service to the end user, right? So that should be deleted and terminated, and the new instance, the LT instance, should be created. So that's how you avoid the problems, right? Because you don't want to. The earlier days we used to troubleshoot if one instance is one VM or a server is not working, then we have to troubleshoot that and fix it, right? So, but in the cloud, we don't need to rely on a single infrastructure. It's not a static infrastructure, so we can just create our own infrastructure. So you have your operation team should be capable to perform all these operations, and they'll be able to understand the infrastructure, how it works in the cloud. So these are the operational excellence pillar. So the next one is more important, I think, the security pillar. So this security pillar, I think many people in the world thinks that cloud is not secure. There are a lot of points to convince them. Like we can say that say as a company, let's say my business is like e-commerce. Let's say I'm an e-commerce business owner, and I'm just concentrating on my e-commerce business. So I won't concentrate much on my security, right? Let's say I'm running my data center, and I'm running my all latest technologies, but the cost what I invest on the security is not that much when I compare like companies, technology giants like Amazon or Microsoft, right? Because they invest more on security. So that is one of the main advantage. Whatever we invest, right? I mean, as a e-commerce company, so we won't invest more on security perspective. Like we won't have budgets to invest on security, right? But as a technology company, so when they provide the technologies to the customers as a service, so they want to be more secure, right? So they invest more on security. So that is one of the main thing what we can say to convince the customers who wanted to go with cloud, but they still worry about the security. And there are a lot of other things you can do, other things you also do, and the cloud provider is also doing for making sure that the data is at rest and data in transit or secure, right? So if you see, there are like regions, availability zones. It's also a shared responsibility model. So whatever compute, storage, database, and networking in the backend, and your on-premises, your premises access, entering access or whatever it is, right? The hard disk and whatever it is. So those will be taken care by the cloud provider, maybe AWS here, and whatever we are creating, the data is what we are creating on the, let's say, on the S3 bucket or EBS or wherever we are storing our data, right? So those should be encrypted, and by a customer. So that is a responsibility of a customer to encrypt those data. And also the operating system, it's not about only encryption at transit, encryption at rest and encryption at transit, right? It's also about your regular patching and other things, right, on the security, like how do you manage your firewalls, how do you manage your threat detection, how is your process to identify the threats and fix that. So there are a lot of things involved, right? So these all to be managed by your customer, by a customer, not AWS, because they don't know what data they are storing, and they don't have access to this data. And also they can't really like protect their data, right, without having access to the data. So it's customer responsibility to protect their own data, and they have to create as a architect. So we have to make sure that the data is protected at all aspects, right? Let it be a encryption on a rest, or encryption at rest, or encryption at transfer. You should use an encrypted mechanism like SSL, or I mean TLS, for data transfer. And you should be using all proper firewall configurations on filtering your packets, and restricting your ports. And you should be having a kind of like proper mechanism to handle your network routing and other things. And also you should be having a proper threat detection systems, or if you are having web URL, so you should have a WAF which should allow your access for the web URLs through WAF, or whatever solution you are going to use. But I'm just saying that you should have a firewall for web. And also you should keep your systems patched regularly, and you should have your vulnerability assessments carried out regularly, and you should do your audit regularly. And also, more importantly, it's our responsibility to even secure our whatever AWS accounts we are creating, right? So the IAM roles, IAM users, the IAM permissions. So we always go with the limited permissions, right? Whenever you are creating a permissions, whenever you are providing a permission for IAM user, you should always think of what that IAM user is going to do, and what the lowest permission or lower permission that we can assign to that IAM user. So that is more important to think whenever you are creating a IAM. So these are different aspects of security, like when you are working on a AWS, because these are comes to your responsibility as a AWS solution architect, who wants to use AWS for the customer, right? Who wants to configure AWS for the customer, right? So this is one important thing. So the reliability pillar, so this is about your high availability, your fault tolerance, whatever the horizontally increase your low workload. So it's about your high availability of your application. So whatever you are deploying. So these are some of the five key points to be considered for making sure that your AWS is reliable, like automatically recovering from the failure, test recovery procedures, scale horizontally, and stop guessing capacity, and manage change in automation. So performance efficiency pillar, again, you have to make sure that you are not facing any performance bottlenecks issues. So you have to use the latest available advanced technologies. Like, let's say AWS EC2 instance type, right? A best example, like if you are using quite old instance types, so the performance may be increased in the new instance at the same cost. So you have to regularly check and update on the the instance types. Just a minute, sorry. Sorry. So the next one is I think a cost optimization pillar. Another major one of the major pillar, like the many of us says that why you will reduce the cost when you are going to cloud, right? So this is one of the considerations. I mean, you have to be well architectured when you are considering that you are saving cost when you are into cloud, right? So because uh, there are some customers like they will be they will not under, I mean the because of their poor architecture, they when they are coming into AWS, so they pay more comparing to their on-premises. The reasons are like let's say they might be thinking that they want to do auto scaling, right? So but they don't change their application how it works in on-premises. They just migrate their application as it is, uh, just lift and shift to AWS. They won't change, they won't they don't want to change the application functionality and how it works. Maybe they don't want to convert it into microservices, right? They want a giant application which just run as it is in the on-prem, and they just want to switch it to AWS and just EC2 instance, and they just enable some kind of auto scaling, right? So they don't know how it will act, right? So maybe the auto scaling will scale up and scale down unnecessarily based on their high usage and other things. So that might cause a lot of additional cost to the customer, right? So they should be able to fine tune their applications before, also because they should understand how my application will act when I do auto scaling for this application in a cloud. So they should be able to understand that, and they should be able to convert it into application which works with auto scaling. So that is some of the important things we should consider when we are migrating to cloud, and when from on premises. Like this is all okay for a newborn like cloud native applications, but when you are migrating from the uh, on premises, so you have to consider all these things before you are migrating. So you have to do some kind of analysis on your expenditures. You have to get your bills, access to the bills and trusted advisory reports, and you have to analyze, and you have to reduce wherever you are spending unwanted spendings. So that will that will help you to reduce cost and keep cost in control, right? So this is one of the major pillar, like when you are doing a architecture of your applications, you have to consider this majorly. The sustainability is sustainability of the cloud. So customer is responsible for the sustainability in the cloud, because we take care of our data design, usage, software application design, platform deployment and scaling, and data storage, code efficiency and utilization and scaling. So only the sustainability of few things, I mean the AWS global infrastructure, which is again owned by AWS, but other things, whatever we are running on top of the AWS, right? So that we have to take care of whatever workloads we are running. So those sustainability part we have to take care as a customer of AWS. So these are the 6 pillars. Maybe I will just quickly maybe name those: operational excellence, security, reliability, performance, efficiency, cost optimization, and sustainability. So I think you know it. Maybe you have already seen this AWS management console. Just have given the screenshot. So you have just you can just go into here and you can do whatever. I mean, since it's a web service, so you can create whatever services you want and you can use it. So I've worked on other AWS other cloud providers like Azure and GCP and even OCI, OpenStack. So, but I feel that AWS interaction with this console is quite simple. Even a beginner can just start their own things on their own, like without having any help. So, but Azure and other things are quite difficult to start. So yeah. Sorry, do you have any questions?
No, sorry.
Okay. So yeah, so these, I just wanted to explain, there are two types of virtualization which AWS supports, HPM and PV. So hardware virtual machine and para virtualized. So this is like fully para virtualized is the latest. This is just a graph like what it supports. The disk and network virtualization in software, and VHS virtualization or hardware, and P is para virtual. So when you see here, the green is optimal performance, and the other scope for improvement and poor performance. So fully para virtual is good. I mean, this is all about your backend virtualization of AWS, how they have virtualized their backend infrastructures. So we are fully virtualized. We are using HVMs, but comparing para virtualized, the fully virtualized HVMs, or the performance wise, it's not that good with good like fully para virtualized. So there's just a graph which explains about this AWS backend PV and HVM. What is PV and what is HVM, or how different they are. So because you might have seen some of the AMIs, so which is like HVM AMIs or PV AMIs. So basically, when you are creating those AMIs, when you are creating launching an instance from those AMIs, so it will create HVM instance. So when you are using, let's say, PV instance, PV AMIs, then it will use a PV instances in the backend. So that's all we see from the cloud, from the console. But in the backend, there are some difference in the visualization technology, how it will be different.
So
So
when we uh, create an instance, we will have the option to select as this para.
no, not really. Let me show you. If you see here, the VM, I mean the AMIs, right? It shows HVM, right? So we can still see. I think.
Sorry, where is it showing? Maybe I missed it.
Sorry.
I think I missed it. Where was it showing, Hemnath?
No, when you try to launch an instance, right, and under
Yeah.
your AMI, right, your
Uh-huh.
AMI. So these are the AMIs. I'm not launching an instance now. I'm just showing you. Maybe browse more AMIs. So if you see, these
Uh-huh.
are the marketplace AMIs. There are list of AMIs available. So if you see here, it says that Amazon Linux 2 AMI HVM, right?
Mm-hmm.
So these are HVM AMIs. So you will, if you see PV, so those are PV AMIs. I don't see anything here. Uh, maybe they have removed. Maybe you have to search for it.
Okay.
Yeah, these are community AMS. So most of them are HVM.
Okay. So this AMI, this PV and HVM, this come into picture when we create AMI.
No, when you create a VM, if
Okay.
you see this is PV, right? PV 2018 03 version Linux AMI, Amazon Linux AMI. So when you are creating a VM, I mean EC2 instance, you need an AMI for that, right? So if I
Right.
select this particular, AMI, so let me show you here. Maybe I'll show you when I'm creating the instance. If you see here, this is just my one of the sample instance what I have. So here the virtualization is HVM, right? So if
Okay.
I create a VM from this AMI, the other AMI, so it will be like PV here. That's what
Got
you will see here. But in the backend, there are some difference technically, like how it is different. That's what I was trying to show here. Like when you are using HVM, so you are privileged instruction page tables, or with it will be visualized in order, and you will get optimal performance there. But all this other things will be like fully para virtualized, is like you will get everything optimal performance. But I think they are not completely PV. I think maybe they are hybrids. So it's all like we are using HVMs only still.
Okay.
Okay, all right. So the next topic is auto scaling. So maybe I'll just quickly give an introduction about auto scaling and what are the types of scaling, and then EC2 best practices. Then we'll go into the lab part. So auto scaling, we have a detailed, in next module also for auto scaling. I think the third module. So auto scaling is one of the main feature of you can say in AWS or any cloud providers for that matter, right? Because you don't get this feature in the on-premises or in the local on-premises servers, right? Because it's not you cannot scale whenever you want, and you can scale up, and whenever you don't want, you cannot scale down, right? So it's possible only on cloud. So this will actually based on your requirement, right? Let's say you have a policy to scale up at a specific time, so it will scale up. The scale up meaning, like, there are two types of scaling. One is vertical scaling and the other one is horizontal scaling. So I can say that is not a type. So that is like something how it works, right? So the vertical scaling is something, you keep updating your instance types. Like let's say, if it is a vertical scaling, like you are using 4 CPU and 8 GB RAM, and if you are increasing that to 8 CPU and 16 GB RAM, then that is called vertical scaling, right?
Right.
But if you are running with one 4 CPU and 8 GB RAM instance, and if you want to create another 4 CPU and 8 GB RAM instance, that is called horizontal scaling, right? So you are adding additional nodes, rather you are adding increasing the existing node size, right? So this is a difference with vertical and horizontal. So I have different slides to explain that. Maybe I just wanted to give a quick introduction on that part. So this auto scaling is not only supported for EC2, it is also supported for ECS, DynamoDB tables, and Aurora. So Aurora is again, as I told, it's a native Amazon database product. So it has a lot of features comparing the RDS. So I think Aurora is one of the native product of AWS.